In this video, we're going to find real zeros of f and use the real zeros to factor f. I'm going to do basically 4 odd problems, 39 through 45, and that's going to be part 1. And then I'm going to continue at 46 through 55 and go a little faster. And we'll go over, so that will be 5 videos, and this one's 4 videos. Okay, so the first one we have for 39 is f of x equals this polynomial. Now, in this case, they're not giving you the c, as we did in the previous video. So we're going to have to find the factors. The first thing we're going to do for step 1 is say, well, f can have at most 3 zeros. Alright, so that means your lead degree is 3. You put this in order, 3, 2, 1. This would be x to the 0. And so it can have at most 3. It can have 2 or 1, but it won't have more than 3. Now step 2 is we're going to do something called use our p's and q's. Our p is going to be the last term, the one that goes with x to the 0. Our q is going to be our first term, or we call this our lead coefficient. Alright? So the p is -6, or we're just going to call it 6, and q is 1. And what we're going to do is we're going to list the factors of p, and I did it a little different than the book. I'm going to put the plus and minus outside, and then we're going to write everything that divides 6. So 1 divides 6, 2 divides 6, 3 divides 6, and 6 divides 6. That means -1 divides 6, -2, -3, and -6. They divide 6 as well. For q, in this case, my q is 1, and the only thing that divides 1 is plus or minus 1. Now your possible rational zeros are p over q. So what we do is we take our p's and q's and divide it. So p over q divided by q equals plus or minus, and basically it's the same as our q. It's 1 divided by 1 is 1, 2 divided by 1 is 1. So it's just going to be 1, 2, 3, and 6, plus and minus. Now, from here, we have to choose which one might be a factor. These are just possible rational zeros. So, and I usually, as a rule of thumb, usually the last one I don't choose. Usually doesn't work with the ones we do in the textbook anyway. I usually use the first set here. And we could, if we wanted to, take f of x and do like we use the factor theorem. So I could take f of plus or minus 1, plug it into my equation and see if I get 0. If I don't, then I could take 2 or -2 and try that, and so on. You could try 3 or -3, and you can plug it in that way. Since I do synthetic division so fast, I just tend to guess and do synthetic division, because this, for me, actually takes longer. So that's just my suggestion to you. So for 39, we know we have, first of all, 3 possible solutions, and I'm going to go ahead and pick something. I'm going to go ahead and pick 3, and I'm going to use synthetic division, and I'm going to have, so I'm going to take 3 as a factor, and I'm going to write down my coefficients. We have 1, 2, -5, and 6. Again, that's from here, 1, 2, -5, and -6. -6. So I'm glad I looked. And then you just do synthetic division. So you bring down the 1, and you multiply 3 times 1, and put it here, and then you add. 3 times 5 is 15. Now, once you do this a lot, you're going to notice that this is probably not going to work. Because you get a 10 here, and you get a 30 here. And for this to be a 0 or a solution, this has to be 0, which it's not. So I don't even care what it is. I just know it's not 0. So I'm going to go ahead and try another one. -3. And the more you do this, the faster it goes. And if you'd have plugged 3 in, you would have noticed that it's not a 0 as well. So bring down the 1, multiply, and we're going to get -3, add -1, multiply 3, add -2. And from here, you can almost tell that it's going to work. So you get a 6 here, and down here is a 0. That means -3 is a solution. So when we started here, this was x cubed, x squared, x1, x0. So we go down 1. So our factor is x minus a -3, which is really what? X plus 3. And then I'm just going to write x squared minus x minus 2. Now I have to factor completely if I can. If I can't factor this, then we're talking about real zeros. We want real zeros. We do not want complex zeros. That means we don't want i's. I can factor this, so my factoring is x going to be x plus 3, and then we're going to have x plus 1, and then x minus 2. So my real zeros are -3, -1, and 2. And that's your answer. And basically, what is a 0? Well, the 0 is where it crosses the graph. So basically, where it crosses actually the x-axis. So it's really your x what? Intercepts. Now we're going to go ahead and write them this way. But basically what it is, it's -3, 0, -1, 0, and 2, 0. Okay? So that's all you're doing. The hard part is guessing here. And like I said, if you want, you can just evaluate it by plugging in the x and see if you can get 0 like we did on the previous video. Okay, the next problem is f of x equals 2x cubed minus 13x squared. My 3's are awful. Okay. Plus 24x minus 9. Now, my step 1 is to see how many at most zeros we can have. So f has at most 3 real, we talk about real zeros, meaning no i's, where that means we don't have to use quadratic equation, which we will next section. And we're going to find out, give us a hint what they are. So narrow down our search. Our p is this guy. That's your p. So our p is going to be the factors of that, which is plus or minus 1, 3, and 9. Our q is 2. So the factors of 2 are 1 and 2. Now, the possible ones are p over q. So if you take these and divide these by 1, you're going to get 1, 3, and 9. And then we also have all these divided by 2, which is 1 again, which I already wrote. So we have 3 halves and 9 halves. Now, like I said in the other problem, I'm probably not going to choose 9. And I really don't want to use these fractions if I don't have to. So you can take these and plug them in your x's here if you want. But that looks like a mess as well, because I'm not letting you use the calculator. So I'm going to go ahead and take a guess on this, and let's see if we can do, why don't we try 3? I'm going to try 3. That's in the middle. I think 9's too big. I don't really like to use that. And I hope we don't have to use the fraction. So I'm going to go ahead and try 3. And write down my coefficients. 2, -13, 24, and -9. Bring down the 2. I'm going to multiply here and add. So you get 6, negative 7, negative 21. Right around in here, you should be able to see that this is going to work. So what we have is, if I rewrite this as an equation, we have a root. This does work because we have 0 here. So what we're going to have is x minus 3 times 2x squared minus 7x plus 3. Now, I'm going to go to the next slide and rewrite that. So we have, we're going to set it to 0 because we're trying to find the zeros. We're going to have x minus 3 times 2x squared minus 7x plus 3. Can we factor this? Let's see. I'm going to try. So I'm going to get 2x, x, a 3. They're both negative because that's negative and that's positive, and 3 and 1. So I need a 7, so I'm going to put the 3 here and the 1 here. This gives me negative 6 plus minus 1, which is negative 7. So when we set this to 0, my zeros are 3, 1/2, and 3. In this case, this is just one. You see this is repeated twice. So the way, you don't want to write it that way. The way you want to write it, or you can even write the equation like this. We have 2 zeros, one at 3 with a multiplicity if I can spell it, of 2, and 1/2 where the multiplicity is 1. Right? Okay. And that's all you have to do. The hard part is guessing the factors. The next one is, let's see which one's the next one, 43. Okay, so we have f of x equals 3x cubed plus 4x squared plus 4x plus 1. Now, it has step 1, it has f has at most 3 real zeros. And to determine them, we're going to find our p's and q's, put the plus and minus outside to make it easier, and the q is going to be plus or minus 1 or 3. So my possible solutions, basically p over q equals plus or minus 1 and 1/3. Now, these, in this case, the 1 actually is easy. You could plug in 1 here and see if it works. And it's not. So you just plug in 1 here and do this mentally. You'll notice that 1 or negative 1 doesn't work. So I'm going to go ahead and try either 1/3 or negative 1/3. And what I'm going to try is negative 1/3. And the reason I'm trying negative 1/3 is because all of these are positive. So if I did positive 1/3, then I'd get a very high or low number. So I think I'm going to do the negative 1/3. And I'm going to go 3. And you'll see what I'm talking about the more you do this. 4, 4, 1. Now you think that fractions are hard to do, but they're really not. So don't be scared of them. If you don't have to use them, don't. But I'm going to bring down the 3. So all you're saying is, what is 1/3 of 3? Yeah, you know, you take a third of $3, that's $1. In this case, since it's negative and a positive, that's going to be a negative 1. You add, 1/3 of 3 is negative 1 again, negative 1/3 of 3, and we get the same thing over and over, is negative 1, and then you have 0 here. That means it is a solution, or a real 0. So our equation would be x plus 1/3 times 3x squared plus 3x plus 3. Now I'm going to use the highest common factor, also known as the greatest common factor, and factor out a 3 here. I'm just going to factor it out and put it up front here. So I'm going to have 3 times x plus 1/3 times x squared plus x plus 1. Now if you notice here, this is not factorable. That means we'd have to use the quadratic formula and you would get i's. So they're only wanting real zeros, so we only have one real zero. It says at most 3, we only have 1. And our real zero is negative 1/3. Okay, I'm going to do one more, I believe, 45. Alright, one more. And that is f of x equals x cubed minus 8x squared plus 17x minus 6. Alright, this kind of reminds me of the first one. So we have at most 3 solutions, or 3 zeros. Our p is going to be plus or minus 1, 2, 3, and 6. And our q is plus or minus 1. So basically our p over q is just our p. You just divide all of these by 1. So that's just going to get plus or minus 1, 2, 3, and 6. Now, what do you think we should do? So y'all tell me, what do you think? 3? I'm probably not going to use 6. It's not going to work. Did y'all say 3? Okay, so let's try 3. That one's in the middle. So I'm going to go ahead and try 3 and see what happens. So we're going to get, or you can plug it in and do it that way, as I said before. So 17 and negative 6. Alright. Bring down the 1. And we're going to get, what number is this? 45? We're going to get 3, negative 5, negative 15, add, you get 2, multiply, you get 6. So that does work. So we get x minus 3 is a factor. Then we have x squared minus 5x plus 2 equals 0. And I think most of you all can clearly see you can't factor that. So we only have one real zero again, and that real zero is 3. Okay? Now, the next video, part 2, is all the ones on this video. Our highest degree was 3. The next video, it's going to be 4, and if I have time, I'll do the 5. You need to watch the next video because most of your, if you look on your review, on your unit test, your problem will be degree 4.